Hi, so welcome to the second video on exponential and logarithmic functions for grade 11. And this photo is something that we have previously discussed, but just putting it here. And we discussed previously about logarithms and exponents with base 10, but now we just extend it to just any base a, so arbitrary base a. So if y is your exponential function a to the power x, then log base ay is going to be equal to x. And some properties is that because a of x and because the function f of x is equal to a of x and g of x, let's say, is equal to log base a of x, these are actually inverse functions. So f compose g of x is going to give you x, and g compose f of x is going to give you x for x greater than 0 and a greater than 0. So what this means is that if you have a to the power log base a of x, then this x has to be greater than 0. This only works for positive x inputs. And similarly, log base a to the power x has to be x. But this is for a greater than 0 because we already discussed that our base, we're going to take it to be positive, and your x has to be greater than 0 for this thing to be defined. And this works because they are inverse functions of each other. When you reflect the graph of a to the power x over the line y over x, you get log base a of x, the graph of log base a of x. So now we're going to try to extend and try to solve questions for any base a. So convert from exponential form to logarithm form. So you take your base, log base 5, and when you raise 5 to 2, you get 25. This is the same thing here. So log base 216 is going to be 4. Right? 2 to the power 4 is 16. And this is going to be log base 3 to the power 1 over 243 is going to be negative 5. 3 to the power this is going to be this. So these are relatively easy questions, and I'm just going to do like maybe the last one here. So log base x of 7 is equal to 5y. This is the form I think that they want. Yes, so this is about it. And I think you can try every question here. Log base a of b is going to be c because a to the power, of b is going to be c because a to the power b is c. So I think this is just what the question is going for. And you can try the rest on your own. Convert from logarithmic form to exponential form. So you want to take your base, raise it to your power is 8. So 3 raised to the power 4 is 81. 8 to the power 0 is 1. 16 to the power 2 is 4, and so on. X to the power y is 5 for this one. For this one, 8 to the power 0 is 1. For this one, 2 to the power 4 is y is equal to 16. Right? So these are very simple questions. So it says solve. So if you have a log equation, and as we previously discussed, then you want to put these values as the exponents of your base. So you want to say 2 to the power log of 2 base 2x is equal to 3, 2 to the power 3. And from this, you get your answer that x is equal to 3. X is equal to 8, sorry. Because here, as we previously discussed over here, because the bases are same, then this side is just going to be x. And then this side, 2 to the power 3, you're going to get 8. So this is the same here. You raise both sides to 3. You put the base has to be 3, and then to the power you can put both sides, and they have to be equivalent. And basically this side you only get x, this side you get 9. So x is equal to 9. So this is just 4 raised to the power 0 is equal to x is equal to 1. And x squared is equal to 49. X is equal to 7. Has to be positive 7. Because we said that our base is going to be greater than 0, right? So actually this equation has two solutions. this equation has two solutions, plus or minus 7, but since our base can only be positive, we reject minus 7 as a solution. So that is how you can approach these questions. These are very, very fundamental, easy questions. So this one, again, 3 to the power 2 is given to be x plus 5. So x plus 5 is equal to 9, x is equal to 4. This is the same thing. 32 is equal to 3x minus 1. So I think 2 to the power 5 should be 32. 16 times 2 is 32. So x is equal to, I think, 11. And let's think about it. 33 minus 1 is 32. 2 to the power 5 is 32. Yes, y to the power 0 must be 7 minus 2x. So 1 is equal to 7 minus 2x. Minus 6 is equal to negative 2x. And you simplify, you get x is equal to 3. And you can always substitute back. Y to the power 0, this must be 1. And when you substitute back 3, you actually see that that is indeed your answer. So we move on. And I'm going through this very quickly because these are not that challenging. These are very basic questions. And once you get the hang of it, it's not going to be that difficult. So again, 3 raised to what power gives you 27? So that's 3 raised to power 3. 3 squared is 9. 9 3 is 27. This has to be 3. 6 squared is 36. 4 to the power half, square root of 4, is going to be 2. This is going to be... Oh, this is good. So how would you approach questions like this? If you don't know how to express this as a power of 2, then one thing you can do is you can use the change of base, and we'll prove this in a later video. But you can use, if you don't know how to write it in the base that you are given, you can say that it is actually log base 10 of 0.125 divided by log base 10 of 2. So this 2 as your base should be in the denominator, and then this should be in the numerator, and you have a common base of 10. And this is something that you can solve using your calculator. And again, I'll show you the proof. We'll go through the proof of why this change of base works. But for now, let's just say that log base 10 of 0.125 divided by log base 10 of 2, that is just negative 3. So actually 2 to the power minus 3 should be 0.125 if you check. So we get here negative 3, right? If you put it into your calculator. And this says that 2 to the power negative 3 should be 0.125. So 1 over 2 to the power 3 should be 0.125. And this says that 1 over 8 should be 0.125. And if you put it in your calculator, 1 over 8 is exactly 0.125. So you can see that the change of base, when we changed our base to 10, it still gave us the correct answer. But we will look into why that is in a later video. So that is simply negative 2. 4 to the power negative 2 is going to be 1 over 16. This, if you simplify, this is just 5 to the power 1 plus 1/2, that is 3 by 2. So your answer is going to be 3 by 2. And I encourage you to do these questions on your own. So I'm going to leave some of the questions for you. Let's look at some of these questions because we haven't done something with base x. But this is, again, fairly simple. You can bring 3 to the front and say that log base x of x is just 1. So you can say, remember that log base a of a is just 1 because a raised to the power 1 is going to give you a. And that tells you that you can bring any exponent to the front. So let me just give you this small formula. If you have something like this, then that is equal to... this can be anything. So if you have log base a b to the power n, that is, you can bring the exponent to the front. So you can have n log a b. It's the same thing. So this can be, you can write this as 3 log base x of x, and log base x of x is just 1. So you directly get 3. And it makes sense even if you think of what the logarithm is as a definition. So this is going to be 1 over 3 because that is the exponent on x. Again, this is going to be x squared 2 plus 1 over 2, that is 5 over 2. So I think you should get 5 over 2 as your answer. This is going to be negative 4. Why? Because you have log base x 1 over x to the power of 4. That is log base x to the minus 4. And that gives you minus 4. Right? If you think about it, what number do I need to raise x to get x to the power minus 4? Well, I need to raise x to minus 4. And all of these is the same thing. Log base x, you're just trying to recall the laws of exponents. 1 squared, you squared this. 3 x to the power cube squared is x to the power 6. So overall, you have x to the power minus 6. So your overall answer is just negative 6. And this is just going to be 5 by 2. The answer to this is going to be x to the power 1 minus 1 over 3 when you simplify this. You have log base x, that is what you're going to have inside, and that is just going to be 2 over 3, and that is just going to simplify to 2 over 3. So please, in case in my haste I make any mistake, feel free to leave a comment in the comment section on where I went wrong, but this is the general idea on how you can approach these questions. So let's solve. 2 to the power negative 1 is equal to log base 3 of x. So a half is equal to log base 3 of x, and basically x is equal to 3 to the power half is square root of 3, right? And this one, so you know that 4, if I raise it to x squared, I am going to get, well, is there a better way to do this? No, I don't think there is. So 4 to the power x squared, it has to be 2 to the 3 minus 5x. And 4 is 2 squared to the power x squared is equal to 2, 3 minus 5x. So 2 to the power 2x squared, because they multiply, 3 minus 5x. If the bases are equal, then it must be the case that the exponents are equal. So I have to solve this quadratic equation, and I'm sure that you have gone through solving quadratic equation in 10th grade. So let's see. What's the solution to this? So quickly revising on how to factor these, you have a sum of 5, you have a product of minus 6. This is how you get your product. So negative 3 times 2 is minus 6, sum is 5. So can I think of two numbers that give me a sum of 5 and a product of minus 6? Well, yes, I can think of 6 and minus 1. When I add 6 plus minus 1, I get 5. When I multiply, I get minus 6. So I can split the middle term now as plus 6x minus x. And this gives me 5x. 6x minus x is 5x. So I have not changed anything. But now I can factor out 2x from the first term, and I get x plus 3. And I want to make sure that I have an x plus 3 in my second term as well. So I can factor out a minus 1 from here. So I'm sure that you have gone through factoring in 10th grade. If you haven't, we'll go through it in the next chapter. I think that is related to quadratic functions. So now you have 2x minus 1, x plus 3 equal to 0. So x can be negative 3. X is equal to 1 over 2. Right? So you set this to be 0 and you set this to be 0, and you get 1 over 2 and negative 3. But let's go back and think about it. Is it possible to... do we have any restriction on x is my question. So if x is negative 3, I don't think we have a restriction. If x is negative 3, then no, because we can solve it for x. So our base is positive, this has to be greater than 0, and yeah, for 2 raised to any power will be greater than 0, whether it's positive or negative, just because of the properties of exponential functions. So yes, so you have two values of x, negative 3 and half. So you can just test these, you can resubstitute and test whether you got the correct answer or not. So you're saying that log to the power 4, 2, 3 minus, one of our answers was negative 3. So if you substitute negative 3, you're going to get positive 15 in the numerator, and you're going to get 9 here. Log 4, 2 to the power, that is 18, equal to 9. And that is 18 log 4, 4 to the half power, right? I know I did a lot of things very quickly. What I did, I brought this to the front. So I have 18 here, and I told you we can do it. Log base 4, and 2 is just the square root of 4. So I wrote this. And when you bring this number to the front as well, you have 18 over 2 times 1, which is 9, which is exactly this value. So my intuition says that this should be fine. But let's try with our other value, which is half. So 3 minus 5 by 2, that's 3 minus 2.5, the 0.5, that's just half, should be equal to 1 over 4. And indeed it is, because you can bring half to the front. You have 2, but like I said, 2 is just 4 to the power half. So when you bring this to the front as well, you have half times half is equal to 1 over 4. Is true. So you can always back substitute and check.